Hello friends, in the diagram video series of class 12 physics, today we are going to learn to draw the diagrams of the chapter current electricity. Okay, so let us begin with the first diagram, that is the diagram of meter bridge, which is a very important topic from the examination point of view. So in meter bridge, diagram of meter bridge to find the unknown resistance. Meter bridge to find unknown resistance. So to draw this, first of all we will draw three strips. So there are three strips you can draw like this. Strip number 1, these are thick copper strips. Strip number 2, then strip number 3. These are three copper strips. You can draw like this. Now there are terminals to connect. Here points are given. Screws are there to connect wires. Now this is called meter bridge. As you know, it has a 1 meter long wire and a 1 meter scale. So there is a 1 meter long wire which is made up of constant ton. You can stretch a wire here, and there is a scale of 1 meter length which is also fitted on a wooden board. There is a scale of 1 meter length. Here, this scale is of 1 meter length, and the left end of this meter bridge, this terminal is called A. We can name it A and we can name it B. Now, to find the unknown resistance, we can connect. There are two gaps. Gap 1, this is called gap 1, and this is called gap 2. And that unknown resistance that you have to find, you can connect here in this gap. The two ends of the resistors are connected in this gap 1. This is the resistance, unknown resistance X, whose value you want to find out, and the known resistance from the resistance box. You know, resistance box you might have used in your laboratory. You can connect in gap 2. This is the resistance box that you can connect here. Now, to operate this meter bridge, you have to connect a battery, a cell here in this circuit, and whenever you are going to make an electrical circuit, you will also connect a key, so that you can switch on or off that circuit as and when you want. Okay, so this is the key, this is the key, you can apply, and this is the cell whose EMF is E. And now you will have to connect a jockey through the galvanometer. There is a galvanometer, you will have to use. This is the galvanometer, and the positive of this galvanometer can be connected at this point, and the negative of the galvanometer can be connected to the jockey. And to find the null point in the galvanometer, in this meter bridge, we have to find the null point. As you know, in the experiment, we have to slide the jockey on the meter bridge wire. But I will suggest you that please do not slide the jockey on the meter bridge wire, because due to that sliding, this wire, the thickness of the wire may change with the passage of time. As you repeat the experiments, the wire will become of non-uniform thickness. So please just put the jockey like this. By touching the wires, you just find the null point. Okay, so this is the jockey. You can touch here to find the null point. Suppose null point is obtained at length L, and the remaining length becomes 100 minus L centimeter. So this becomes the diagram. This is your diagram is ready to find the unknown resistance. Using this diagram, you can easily find the value of unknown resistance using meter bridge. Now we will discuss to draw the diagrams of potentiometer in this series. Okay. So potentiometer is a very wonderful instrument. It is used to measure the accurate EMF of the cell, or to compare EMF of two cells, and using a potentiometer you can also find the internal resistance of cell. So let us study about potentiometer. Let us learn how to draw the diagrams of potentiometer. Potentiometer, as its name implies, potential measuring device. This is called potentiometer. So I will let you know how to draw a simple potentiometer, basic potentiometer. In a basic potentiometer circuit, there is a driver cell and an ammeter and a variable resistance, that is rheostat. Okay, and a key you can also apply, so that you can switch on or off the circuit as and when you want. And there is a wire which can be of any length. This wire is AB. The left end of this potentiometer wire is A, and the right end of the potentiometer wire is B. So this resistance is R, and the the driver cell EMF is E and this is the key K. So this is the basic circuit of simple potentiometer. So potentiometer, now as you close this key, some current will start flowing in this potentiometer circuit. Okay. Now we'll learn to draw the use of potentiometer to find the EMF of a cell. If you want to find the EMF of a cell, what you do? Primary cell, I mean, suppose this is the primary cell whose EMF you want to find out. So what you do? You just connect the positive of this cell to this left end A of the potentiometer wire, and the negative of the negative terminal of this cell you can connect to the galvanometer. Right. Now you can use a jockey. Suppose the EMF of this primary cell is E that you want to find out. Now you can use a jockey to find the null point on the potentiometer wire. Suppose this is the jockey, and if you just provide the contact with the wire, suppose you find the null point at point J at a length L from the left end A of the potentiometer wire. So actually by finding the null point, what you are doing, you are just trying to balance the EMF of this cell across the potential of the length of the wire. And if suppose at this point you get the null point, that means the EMF of this cell is equal to the potential of L length of the wire. Okay, so using this diagram you can easily find the EMF of a primary cell using a potentiometer. Now we will learn how to use a potentiometer to compare the EMF of two cells. Potentiometer to compare EMF of two cells. Now to use this potentiometer to compare EMF of two cells, suppose two primary cells, what do? You just make two cells, suppose you have two cells, suppose this is the basic circuit of potentiometer again. This is the basic circuit of potentiometer, and here you can draw two cells whose EMF you want to compare. Suppose this is the first cell and this is the second cell, and you want to compare their EMF. Suppose the EMF of this cell is E1 and the EMF of this cell is E2. Okay, now the two ends of the negative terminals of these two cells can be connected to a two-way key. This is two-way plug. This is called two-way key. Okay, so this point can be connected to a galvanometer and a jockey. Now there are two gaps in the two-way key. This is the gap 1, this is the gap 2. Now to compare the EMF of these two primary cells, what do? First you insert plug in this gap 1. As you insert plug in this gap 1 and you slide the jockey, so if you insert plug in this gap 1, so this cell, EMF of this cell comes in the circuit and this is out of circuit. Okay, and you find the null point. Suppose null point is obtained at length L1. So the EMF of this cell is balanced by the potential of length L1. So you can write simply E1 is equal to KL1. Similarly, if you remove the plug from this gap 1 and you insert plug in gap 2, if you remove from this here and if you insert plug in this gap 2, so this cell comes in the circuit, and you will have to find the null point by just providing the contact of the jockey with the potentiometer wire. And suppose if you find the null point at some length, other length, suppose this is L2. Suppose this is the length L2 at which you find the null point for this cell. That means the EMF of this cell is balanced by the potential of the length L2. So you can write there simply E2 is equal to KL2, and using this diagram you can easily compare the EMF of two primary cells using a potentiometer. Now I will let you know how to use a potentiometer to find the internal resistance of a cell. Right? Use of potentiometer to find internal resistance of a cell. Internal resistance of a cell. Okay. Suppose this is again the basic circuit, primary circuit of potentiometer. This is called the basic circuit of potentiometer. Again, I let you know that there are four basic components. This is the EMF of cell E, and the variable resistance your rheostat. Using this rheostat you can adjust the current in the potentiometer circuit. The desired amount of current can be passed by increasing or decreasing this value of resistor, and this is the key which can be closed to make the continuity in the circuit, and this is the ammeter which can be used to measure the current flowing through the potentiometer circuit. Okay, now suppose you have a cell whose EMF you want, whose internal resistance, suppose this is the primary cell whose internal resistance you want to find out, and the internal resistance suppose is small r, you want to find out, and suppose to do so, what we do, we connect an external resistance, you can call it shunt S, and the two ends can be connected to the two-way key. Again there is a two-way key in this also, these two can be connected to two-way key, two-way plug, and this point can be connected to galvanometer and jockey. Now in this is the diagram ready for finding the internal resistance of a primary cell using a potentiometer. Now to find the internal resistance of primary cell, what you do in this experiment, first of all you will insert plug in gap 1. As you insert plug in gap 1 and this is open, you can see, so this resistance is not included in this circuit. Okay, so this is out of circuit, and again you find the null point, and suppose null point is obtained at length L1. So the EMF of this cell, if this is out of circuit, so EMF of the cell is balanced by the potential of length L1. EMF of the cell is balanced by the potential of length L1, and you can simply write E is equal to KL1. Now you will insert plug in both the gaps, in gap 1 as well as in gap 2. So as you insert plug in both the gaps, both the gaps are connected, so there is a circuit. A circuit is formed here. This is called secondary circuit. You can see here, this is a secondary circuit. Now it is closed. Now you insert plug in both the gaps. So this is a secondary circuit, and this cell starts providing current in this circuit. As this cell starts providing current in this circuit, so the EMF, the potential difference across this cell will not remain EMF, and it will become TPD, terminal potential difference, because you know some potential drop always takes place inside the internal resistance of the cell also. So when the circuit is formed here, suppose this circuit is carrying current I dash, so potential drop I dash into R, this much amount of potential will take place inside this. So the voltage across this will not remain EMF, and it will become less than EMF, terminal potential difference. And now if you will find the null point, balance point on this potentiometer wire, so to balance that lesser value of you can say terminal potential difference, you will have to take lesser length. So you can find easily null point at some lesser value of length, suppose L2. Okay, so this is your diagram to find the internal resistance of a cell, primary cell, using a potentiometer. So this is I have used in this circuit the simple potentiometer, a single wire potentiometer. Now there are potentiometers having 4 wires, 8 wires and 10 wires available in your laboratories. So I will let you know how to draw the 4 wire and 8 wire potentiometer circuit. Okay, the same 4 wire, 8 wire potentiometer circuit can also be used, because this is simple single wire potentiometer. As we increase the number of wires in a potentiometer, the sensitivity of the potentiometer increases. The greater is the length of the potentiometer wire, more accurate reading it will give you. The exact value, to find the exact value of EMF, we should use a potentiometer with maximum length, you can say greater number of wires in the potentiometer circuit. So let us learn how to draw a potentiometer with 4 wires and 8 wires. Okay, a 4 wire potentiometer, let us learn how to draw a 4 wire potentiometer. 4 wire potentiometer. So to draw a 4 wire potentiometer, what we do, actually we make a box here, and this is you can say one end of the potentiometer wire, and you can make 4 wires, wire 1, wire 2, wire 3 and wire 4. And you can put another end of this potentiometer wire at this. So these are the 2 ends, end A and end B. This is the end A of the potentiometer wire, and this is the end B of the potentiometer wire. Now you can connect the ends of the wires by using 3 copper strips like this, this. So these are the thick copper strips, and their role is just to connect this wire to this end to this end, and their resistance should be negligible. So to minimize the resistance of these connecting wires, we have used here thick copper strips. Okay, so this is the potentiometer wire. You can see it is a potentiometer having 4 meter length wire. Now you can connect other 4 components that I have already told you. That is number 1, your key, so that the circuit can be switched on or off at desired time. Now you can connect a variable resistance R, and an ammeter you can connect here. Ammeter, you can connect an ammeter, and then a driver cell. So these are the 4 basic components that you require in a potentiometer, and you can connect it to this end A. So your 4-wire potentiometer is ready. Now you can see that here is a cell of EMF E, and a meter, and a variable resistance R, and this key. As soon as you close this key, current will start flowing in this primary circuit of potentiometer. So this is simple 4-wire potentiometer. Now similarly you can draw 8-wire potentiometer. Let us see how to draw a 8-wire potentiometer. So to draw 8-wire potentiometer again, you can make, starting with the simple one end of the potentiometer wire, that is box 1. You can draw one box, and you can draw 8 wires. Wire 1, wire 2, wire 3, wire 4, wire 5, wire 6, wire 7, wire 8. You can draw 8 wires like this, and this is the other end of the potentiometer wire. You can name it A, and this end you can name B. And you can connect the ends of this potentiometer wire by using thick copper strips like this. Thick copper strips can be connected at the ends. So your potentiometer is ready. You can see this is potentiometer, and now you can connect 4 other required components. That is number 1, what is the key, then a variable resistance, that is rheostat. You can connect. Then you can connect an ammeter to measure the desired amount of current flowing in the potentiometer circuit, and then you connect a driver cell, or you can call it auxiliary battery in the circuit. So this is your ready 8-wire potentiometer. So this is the way how to use a potentiometer for practical purposes, to find EMF of a cell, and to compare EMF of 2 cells, and to find the internal resistance of the cell. Thank you. Please see my videos again and again, and like them and share them. Thank you.